Okay, welcome. I'm going to be talking about JShell, which is a new tool in the JDK platform for interactively using Java code. I'm Robert Field. I'm the architect of JShell and the lead engineer. Hasn't shipped yet, so who knows that's what that statement is. So what we'll talk about. First of all, what is JShell? Why would you be interested in using JShell? And how do you use JShell? What's involved in using it? I'll do a demo. And then I'll talk about the architecture of JShell and really very briefly the JShell API. And then I'll have time for questions, but I'm open to questions at any time, time permitting. Okay, first of all, what is JShell? But before that, who's heard of JShell before this Devoxx? Okay, that's shifted. Okay, like a year and a half of Devoxx in Belgium, like almost no one raised their hand. Who hasn't heard of JShell before this Devoxx? 2 people, okay. And who's actually used JShell? I know, well, there's one, well, a little bit over there. Okay. Okay, what is JShell? It's a tool for dynamically interacting with Java. It's one of the class of things of read-evaluate-print loops. So that means it takes a snippet of Java code, declares it, runs it, and you immediately see the results. So REPLs are something you see in JavaScript and Perl and a bunch of other languages. And now we have it as part of the JDK platform. And it, in fact, is deeply integrated in the JDK platform. Not only is it inside the JDK, but it's built on top of the JDK infrastructure. It's built on top of the Java virtual machine, on top of the Java compiler. Okay, so what I'll be showing you in this is the JShell tool, which is a lot easier to show than an API. And it's probably what most people will use. But that tool is built on top of an API, and the API is actually where all the good stuff is. The tool is just kind of a shell on top of that. And that's because really feel this functionality is useful in all kinds of applications and in other incarnations of a REPL. So what's JShell NOT? This is not a new language. This is snippets of pure Java code. There's no new syntax. Nothing was added except for the ability to just use snippets. And nothing was removed except for things that don't make sense. And I'll have a slide on the details of that later. This is not a replacement for the compiler or an IDE. This is for exploring code. And if you're going to write a program, you're still writing a program with the tools you're familiar with. So why JShell? There's 3 kind of overlapping audiences that are that JShell is useful for. One is people that are new to Java programming or new to programming, period. And that's because it's really good because you can start with expressions or statements rather than jumping into whole programs with classes and main methods and so forth. And it's also immediate feedback, which of course is also good for learning. And we're all newbies at one time or another, still, because we encounter new APIs that we're dealing with or new language features. And we get to experiment and instantly see results. It's also useful day to day, like, okay, how am I going to do this exactly? And you can kind of do micro testing of pieces and make sure that you've got your code right before you add it to your program. Okay, so currently everybody knows how you go about programming in Java. You have to write a class with imports and a main method, and you use either an editor or an IDE to write that, and then you compile it, and then you execute it, and if something's wrong, you repeat that cycle. So in white is what you'd have to, let's say we just wanted to know, run a little experiment, what's the difference between signed and unsigned shift on a negative number? So we need to write a class and main method, some print statements, and then we can test it, we compile it, we run it, and we see, oh, whoops, the format of that result isn't very interesting to see. We probably want to go back in and change it to an octal output. So cycle through again. What about in JShell? You just type in a snippet of code and you immediately see its behavior. So now in white is what you would type, in this case, in JShell. You just type the expressions. And the result is what you see on the right over there, so it's -2. On the left is a temporary variable that's created so that you can basically access that result later. Same is true, of course, in the other case. There's another temporary variable. And then we see that we want to print an octal, and we can just print it. Okay, how do you go about using JShell? So if you have JDK9 installed, you have JShell. You just type JShell at the command line. The JShell tool takes two kinds of input. One is the snippets, talked about, which are little consistent pieces of Java code, declarations, so forth, and then it executes them. And it also takes commands, which give you information about what you've done, allows you to control things. Either of those can be tab completed. You can tab complete a command argument, or a snippet. Okay, snippets. They can be a variable declaration, method declaration, class declaration, interface, import. If you can declare them in Java, you can. They're a snippet in JShell. Excuse me. Oh my. Okay, expressions. Anything from a constant to a method call, or a complex stream expression. They're all valid. Again, if they're a Java expression with appropriate context, they're valid in JShell. Same with statements. For, while, if. The only things that aren't allowed is JShell code is self-contained in JShell, so package is used for making things accessible elsewhere. The package command doesn't make any sense in JShell. And you can't use, in Java, you can't use static as a top-level modifier, and you can't here either. And everything's dynamic in JShell, so final doesn't make sense. Then there's constructs that have to be inside of a for loop or switch or method. Of course, they don't make sense just loose. Those are the only things you can't do. Commands. So there's lists that shows you the snippets you've defined, you've entered. There's vars, which show you the variables and their values. There's methods, which shows you methods and their types. And there's types for classes, interfaces, et cetera. And imports. So there's built-in like line editing in the JShell tool, but sometimes you want to edit things as a whole, and there's an edit command which is configurable to use different editors. You can say, I don't want a particular snippet as part of my world. You can drop it. You can save your set of snippets or your history. You can reopen them and have them reevaluated. Session things, well, you can exit. It's always good. And then the other three commands are for kind of resetting the state potentially with reloading. So an environment allows you to change things like your class path or module path, and then reload things in that context. Reset just kind of scrubs your world, and you can access your history. There's an extensive ability to configure your environment, basically what kind of feedback you get, your prompt, everything. And that's all in set. And then there's help for all of these things. So for example, if you do help on LI, all the commands can be abbreviated to the point they're unique. So LI is unique for list command. You can say help LI, and it shows you the various kinds of lists you can get. And the set command's fairly deep, so I'm just going to give you the basic idea of the kind of things it can do. So there's a built-in editor. So first it tries to use if you have an editor setting, it uses that. Otherwise, it uses your built-in editor. Unless you've set the editor command, you can use any operating system editor you want. When JShell starts, by default, it gives you a set of kind of really common imports. So you don't have to do some simple thing, you don't have to do an import. You can change what that startup file is to anything you want. And there's also pre-existing things, like I used printf in that first example. There's a startup file that has all the print line, printf, so forth defined. Next, there's predefined feedback modes like verbose or concise, and or you can define your own, and that allows you to set what feedback mode you want. And then the next four are basically for constructing your own feedback modes. Creating the mode, setting the prompt, setting truncation, and all the complexities in format, which is basically what kind of feedback you want for different things. And finally, all the set commands without an argument, including just set, show you your current settings. Okay, this is what it is now, but in a couple weeks, we'll be changing it to this, so that's what I'll show you. These are, so people have, well, these are JShell specific keystrokes. So if you're in the middle of typing an identifier in a snippet and you hit tab, it will do command completion for you, completing it to if it's unique or show you the options if it's not. If you're at the beginning of a method called parenthesis and you hit tab, at that point it will show you method parameters. It will show you all the possible signatures for that method. And if you hit it again at that point, you'll get the javadoc. Now, people, I know before we're getting feedback, well, why don't you add a var command? And a lot of the REPLs have that. Well, so once again, we're not changing anything here. But this is probably as good. So basically, if you've written an expression and you type Shift-Tab-V, it will turn that expression into a variable declaration. It'll compute the type of the expression, use that, and put you in a place to enter the name of the variable. And if you're at the end of an identifier, needs to be imported, you can do Shift-Tab-I, and it will give you a menu of possible imports that match. Control-C, you can Control-C a running process or borderline. Control-D, you can exit. So underlying all this, the JShell tool is built on JLine 2, which is a read-line implementation in Java. So it gives you all the kind of common editing things you might be used to from Emacs or something. You can navigate with the arrow keys through the line or through the history of what you've entered. If you hit return on any one of those lines, including in history, that enters the line you're on. So I won't go through all these in detail, but you can do Emacs type editing like Control-A, or Control-K to kill, or even define keyboard macros. Okay, a demo. PowerPoint crashed, that's sweet. No, that's not what I want. Okay, so to start JShell, you just type JShell. Okay, and so we can define a variable. Let's say string s is hello. So again, it shows you the value on the right and the variable it's in on the left. In this case, we've already said what variable it is, so it doesn't create a temporary variable for us. Anytime we have a variable or anything else, we could want to know its value, we can just enter it and it'll show us. So we can use tab completion here. Let's say, what operations can I do on string again? I can hit tab and it'll show me all the things I can do with tab. So let's say we want to convert it to uppercase. So I can go, oops, I can only type T up. It makes that unique, and hit tab again and it'll complete it to uppercase. But notice some of these have closed parens also. That means the only definition is one with no arguments. But this has an open paren, so there's clearly some potential arguments to uppercase. I hit tab. This would be after the paren of a method call, so I can hit tab, and it'll show me the signatures available. So if I wanted to pass in a locale, I could. I'm not interested in that. And there's my value again. It creates a temporary variable 3 with hello. Just to give an idea of what, so you can use that at any point. Okay. So how do you edit things in line here? Let's say we want to create a method that shows you half of an entered string. We can, so I know it's sub something, oh there it is, substring, and it can complete it, and length, divided by 2. Okay, and it says we've created a method half with an argument that's string. Well, let's try calling that method and see if it works. Well, we got half of the string, but I wanted the first half, not the second half. What do? So I just go up with the up arrow twice, and that takes me back to the method I was in. And I want to start from 0, go to the halfway point. Let's try it again. Again, go up twice, and hit return. OK, there we go. I got half of my string. Any questions so far? Yes? What version of the JDK? This is the latest one, 161, but it hasn't changed much. I mean, we're in a stabilization part of JDK 9, and there's been a few bug fixes, but it's been in there for a while. None of this would be any different. The tab, when I'm saying tab for at the end of a parenthesis, for example, that's not in even our development stuff yet, but we'll be changing that. So I'm telling you what it will be in 3 weeks rather than what it is now, because that's not very interesting. OK, so when you're programming, sometimes you have to forward reference things. But also, if you're just kind of doing things on the fly, you may want to forward reference things just because you're figuring it out as you go. And it certainly happens to me. So let's say we want a method for the volume of a sphere. OK, let's call it volume. And we'll have it take a radius. And I know the formula is 4/3 of pi times the cube of the radius. Well, we haven't actually defined pi or cube yet, but we're going ahead anyhow. And it actually allows us to define this method. It says, yes, I've created this method, but it says it can't be invoked until you define pi and the cube method. Well, one way I can define something is by importing it. So let's import static Java lang. Notice I'm using tabs a lot. I'm a really lazy typer. No, not math. Star. OK. Notice something else about everything I've typed here is I haven't put a closed semicolon. So the terminal semicolon can be omitted within the tool. Internal semicolons, like inside that method definition, are still required. OK, well, now let's try calling vol. I would define, and it's like, whoops, no, you can't do that. You're still trying to call it even though you haven't defined cube yet. Now, up arrow a couple times, back to the volume call. Let's try it again. Well, this time I let it run. Anybody see anything wrong with that? It's supposed to be 4/3 pi, and that's pi, so something's wrong. And what happened was we're doing integer division, and so 4 divided by 3 is 1. Let's make that floating point division. and do up arrow a couple more times and try again, and we've got a result. All right, at this point I'm going to head back to the slides. Assuming it lets me do that. Come on. That's right, PowerPoint crashed, so now I have to restart PowerPoint. You take me back to the beginning, or? Yeah, all right. So, excuse me, I'll need to get us to the right place. Okay, now let's talk about the architecture of JShell and the API. So going into creating JShell, we knew there'd been some attempts to do this before. They'd be based on interpreters and so forth. We wanted something that was going to stay current, and we didn't want to be in some situation of chasing corner cases of going, well, ours does this, this does that. We wanted to be, and the way to do both of those things was to be based on top of proven technology, and so that's what we've done. We built it on top of the compiler and on top of the virtual machine. And then how you interact with it, we wanted to be easy and natural. We did a lot of work to try to do that, and we're still open for feedback. And for the tool, we decided we're the tools and libraries group, but we're not a UI group, so we were going to stick with a command line tool. I'd personally prefer a GUI tool, right? So if someone wanted to do that, it could be easily done with the API. Okay, let's look at the architecture. Okay, the big orange box is the core implementation of JShell. So as I mentioned, the parsing compilation stuff is built on top of the Java C compiler using the compiler APIs. The execution part, well, let's first skip to the punchline, is built on it uses a JVM. It uses a JVM in a remote process, which means if you do something that crashes your JVM, it doesn't crash your tool. So to control that, we use the Java Platform Debugger Architecture through the Java Debug Interface and some of our own control mechanisms. But that's actually just one way to do execution. We have the JShell Service Provider Interface, which allows you to choose execution, what execution engine you want to use. Now, most people wouldn't be interested in that, but for specific applications, for IDs and so forth, you can plug in the execution engine you want. Okay. So what the JShell implementation provides is the JShell API, a way to evaluate snippets of code. And the JShell tool is built on top of that. And for user interaction, uses the JLine 2 library. And there's a small little API for launching, which basically allows you to configure a tool and start it. So there's, so you see kind of, well, let me go to the next slide. All right, so these are the packages within the JShell module. The module is called JDK JShell. So the JDK, JShell is the API. That's what, if you're going to use a tool that's, you're going to build a tool on top of the API, that's what you'd want to use. Then 3 down is that service provider interface for changing out execution engines. The one above it is basically a library of components for execution engines. And then finally, the bottom is JDK JShell tool is for launching the JShell tool. And the command line launch goes through that API too. Okay, a really 20,000-foot view of the JShell API. So you get a JShell instance, and once you have a JShell instance, you ask it to evaluate a string, which is a snippet of code. And that produces basically, well, actually a list of events, of snippet events. And they hold snippets, which are a representation of a Java snippet. And you can make all kinds of queries on that, including its status. Off on the far side, there's this source code analysis chunk, which allows you to do basically completion analysis and things like that. That's, you saw the tool using that. When you hit tab, it's basically calling that completion analysis. So all the kind of interesting pieces in JShell are built on the API, so other tools could use them as well. Okay. Actually, at this point, I think I still have plenty of time. Yep. All right, I'm going to switch back. To cooperates. So I can do a meta example of using the JShell API, kind of just exploring it and creating a mini JShell tool from within the JShell tool. So let's say, but before we do that, so I used that printing thing before. I'll show you a little piece of set. So this, here's the set command, and we want to set start. And if you use retain on a set command, it will retain that setting for future invocations of the tool. So we want the default imports that we typically get plus printing support. And then we're going to exit. Oops. And then we'll just do JShell again. And to see that we got what we want, once again, if you do a set command with no argument, shows you your setting. It says my setting is set start retain default printing, and then it shows what default is, which is those imports, and what printing is, which is defining all those print and print line and printfs. It's kind of gratuitous. We're only going to use print once in this, but I just want to show you how set works. Okay. So we saw on the slide that you have to have a JShell object to use JShell. So let's just start. We know we need a JShell, but we don't know. I forgot where that comes from. So I can use Shift-Tab and I, and it will show me where I can import it from. It allows 0 to do nothing, or 1 to import from JDK, JShell. Now we're back to where we are, but JShell's imported. Okay, what can I do with a JShell? Demo effect. That's interesting. I don't know why that is. There's some keyboard thing happening here. Works now, okay. It's never happened to me before, but of course it happens now. So amongst those options, clearly we want to create a JShell object. We'll probably want to put it in a variable to use. So I can do Shift Tab V. So it knows the type of object being created is JShell and puts me in a position to name it. I'll call it SH. And so what can I do with a JShell object? All kinds of things. I can do all kinds of queries and so forth. And basically, a lot of things that correspond to the commands we saw. But what I want to do is evaluate. And let's say we want to evaluate this declaration of variable x. Notice this has a semicolon because this requires complete valid snippets. The tool using the source code analysis to decide when it can add a semicolon for us. Okay, that created a snippet of a list of snippet events that look like it only has one snippet in it. And it put that in temporary variable 3. And we're going to just like cheat and get that first one out. And that's going to be our snippet event. So, and here it gives me three choices for creating the variable. It can do nothing, create the variable, or import snippet event for me and create the variable. That sounds like what I like. And let's call it EVT. Okay, I've got this event. What can I do with it? Because the query is on event. Let's look at its status. Well, it's a valid snippet. That's good to know. How about getting its value? Yep, it's 5. Notice the value is a string. The values returned are strings. I have more of this. I'm not sure that's that interesting. So I'm going to go back to the slides. Okay. Oops. No. So JShell is part of the JDK 9, so it will ship when JDK 9 ships, which I looked up on the web as July 2017. It's accessed. You can get early access builds through java.net. The source code is available as part of the source code, of course, of JDK 9. It's in the Lang Tools sub-repo and in the JDK JShell module. There's a JEP that corresponds to JShell. It's 222. And this is very much a work in progress, and I'm going to find a better place for it to live, but I'm working on a tutorial for JShell, which currently resides here. The official Oracle docs team has kind of just started, so I'm not sure what they're going to create. So the engineering team is myself, Robert Field, Jan Lahoda, and JDK 9 committers, of which currently there's only one, Shinya Yoshida. And we're definitely very into the open source thing, so if you want to be a contributor on this, we'd be happy. We're probably talking about releases after JDK 9 at this point. Lots of people are very involved in the process. Certainly, Brian Getz and the rest of the Lang Tools team, and lots of good reviewers and cheerleaders and so forth. And I'm open for questions. Of course, yes. Is it possible what? Yes, yes. So you can on the /m command or on the command line use class path or module path. So that's one approach to do that. Yeah, of course. That makes it a lot more interesting when you can interact with an existing library of code. What do you mean? Right. So there's currently no way to do that. It's potentially possible. And actually, you notice I said that thing about the SPI. With an SPI implementation, you could do that. And at least one IDE vendors, we've talked a little bit about that happening. But first, they have to have a production implementation. Any other questions? Where do we want to go from here? One thing is we want to make the tool more configurable, so be able to kind of define the ability to add functionality to the tool, which means the ability to push things down into the execution side. So, for example, you want to, instead of displaying results as strings, you can pop up a graph or something. That's just one example of just an extensibility mechanism. Other questions? All righty, thank you very much.